When it comes to finding domain and range, there are certain guidelines or rules to follow. For example, for domain, we are always going to look from left to right of the graph here. And for the range, we're always going to start from the bottom going all the way to the top. For our answer part, or when I'm just asking you for domain and range, you give me interval notation, and the format would be with brackets or parentheses for both example where the lower bound or the lowest value is on the left side and the upper bound or the greatest number will be on the right hand side. Now here is a number line where 0 is in the middle, the lowest would be negative infinity, the greatest would be positive infinity, the symbol. You only use this if the graph is continuous, and you would know that it's continuous if it has arrows. Just like these two right here, the graph have arrows, that means it's going to go on forever, or to negative infinity or positive infinity. And when you have multiple domains, multiple range, you can have 2 domains, you can have 3 range. So if that ever happens, we're going to use this symbol, the U symbol, for AND. So let's take a look at the first example. Now you can see it's one line, one graph function, and the increments on the axis are by 2. So 2, 4, 6, 8. Y-axis, same thing, -2, -4, -6, -8. Now, we're not going to pay much close attention. The reason is, as you can tell, both ends have arrows, so they're going to go on forever. So let's take a look at domain first. So I'm going to start at the left. Well, before we do that, as you can see, right here, even though it looks like it's going straight, in fact, this side of the graph is going in 2 directions. We know it's going to go up for sure, but as you can see that it's a slight to the left. So it's going greatly upward, but it's slowly increasing towards the left. So it's going up and it's going left. If you take a look at the bottom over here, it's slightly going towards the right. So we can see that it's slowly increasing towards the right when it comes to domain, and we can tell it's greatly increasing towards the bottom. So when we look on the left side, we know that it's going up and left. On the right side, it's going down and right. So just to remember, going to write up and left. Sometimes writing this will help identify domain and range. So now we're seeing the graph is going up and left, right side, down and right. So for domain, we're going to start with the left. So we know that it's going towards the left forever or continuously, so we're going to use negative infinity for continuous. Now since we know that it's going to go towards it but never reach negative infinity, we're going to use parenthesis, not bracket, parenthesis. Now if we're looking for the right hand side, we're looking at the domain, it's going towards the right forever or continuous. We're going to use the symbol for infinity. And then close parenthesis. I forgot to put the letter for domain. So towards the left side, going continuously, we're going to use negative infinity. Going towards the right side, continuously, we're going to use positive infinity. Now let's do range. Now let's write the letter from range. Alright, so starting from the bottom, as you can see that it's going downward continuously because of that arrow. So negative infinity for continuously, downward again, and parenthesis. Then we're going to look at the top with an arrow, so it's going upwards continuously. So it's going towards positive infinity with a parenthesis. Now, the reason we're using negative, because if it's going towards the left side, you're going to be going through the negative numbers for domain. Going towards the right side, positive numbers. So negative, positive. Same thing applies to range. If you're going downward, you're dealing with negative numbers, so going towards negative infinity. Going upward, you're dealing with positive numbers. Alright, so that's it for example 1. In example 2, we have a graph of a square root function. So, even though this does not have arrows, it can also mean that it starts here. So, I'm going to write a little dot saying that it starts right here. Now, that's okay. We can do this when we're dealing with square root function, or again, graphs of square root function. So you can see there's another arrow. That means that it's going to go continuously. So this one, different from the first example, you can definitely tell it's going sideways. So it's definitely going towards the right. So I'm going to write an arrow for towards the right. And then it's going downward. Because you can see it's going slowly downwards, but also greatly at a great speed going towards the right. So now we know this graph is continuously going towards the right and continuously going down. So let's start our domain and range. So again, the increments on the x and y axis is by 2. So the letter for domain. Now, here's you have to be very careful when we're using parentheses and brackets for interval notation. So, since we're looking at domain, we only worry about the numbers on the x-axis. So look in this graph, it starts when x is 1. So I'm going to write 1. And since it's right at the, what you call the intersection, I'm going to use bracket with a comma. And then looking at the right arrow for domain, going continuously. So if it's going continuously to the right, I'm going to use positive infinity. But we have to use parentheses. Now for range, we're going to start where the intersection is, but we're only going to focus on the numbers on the y-axis. So look at the y-axis, we can see that it starts at -2. Well, actually, let me go back. Lower bound, upper bound. So, if we look at the down arrow going downwards continuously, it's going towards negative infinity. So, if we compare negative infinity and -2, well, the lowest value is negative infinity. So, we're going to put negative infinity first, because following the format, lower bound. And then here, this is where it ends in terms of range, so -2. So negative infinity, parenthesis. And then you can see that the graph hits the intersection right here at -2. So I'm going to use bracket. So your domain of this function is 1 to infinity, and your range is negative infinity to -2. Okay? For example 3, we have a graph of a rational function, and there are two lines, two graphs. So that means the possibility of 2 domains and 2 range. So to make our work easy, we're going to make arrows on the left function. So, well, actually, this is going to be 8 arrows in total. Here's why. So it's slowly going to the left and upward, and then here going downward towards the right. Now over here it's going upward and towards the left. Over here it's going to the right and downward. So it seems a bit confusing, so we're going to take it one step at a time. Alright, let's talk about domain, just domain. So I'm going to use the letter for domain, and then we're going to start from the left side. Let me make some room so you can see. So domain, we're going to start from left, moving towards the right. So since there's an arrow here, that means it's continuously going to the left. Continuously going to the left, well, that's negative infinity. Now here's the right arrow. So when you have rational functions, these dotted lines are called asymptotes or bounds. That means that the graph line will go towards the bounds or the asymptotes, but never touch it, never cross it. It will continuously going closer, 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 and then it will never cross the boundaries or the asymptote. So if you look closely, we have an asymptote on the x-axis at -2. So we can see that the graph function is going towards the right, towards -2, but will never cross it. So when it never cross it, it means it never reach it. So we're going to write -2 because the graph is going towards -2 on the x-axis, but never reach it. So I'm going to use parentheses. Going towards -2, but never reach it. Now we're going to talk about the domain of the right function. So I'm going to use that symbol for and. Now here we have a left arrow. So same thing. It's going towards the left on the x-axis of -2. The asymptote, it won't go, well, it will go towards it, closer, closer, and closer, but never cross it. So I'm going to write -2 with a parenthesis, and then looking at the right arrow, and there's the arrow on that graph function, so continuously to the right, that means it's positive infinity. So a symbol for infinity with parenthesis. So our two domains is -infinity to -2 for the left function, and -2 to positive infinity for the right function. That's just for domain. Now we gotta do range. Alright, so we're gonna look at the up and down arrows. And keep in mind that these graph function has arrows at the ends, meaning continuously. So we're gonna start at the bottom, which is this one right here. So we can see that it's going downwards. So in terms of the y-axis, the y numbers right here, so negative numbers, if it's continuously going downward, that means that it's going to go towards -infinity. So the lowest number, or the lower bound, -infinity. Now again, we're doing the range for the left graph. Now as you can see that it's going upward, but you see there's another dotted line, so that's the horizontal asymptote. So it's going upwards, 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 and then curves going towards the asymptote. So in terms of the y-axis, the horizontal asymptote crosses the y-axis at, it seems, in the middle, so 0.5. So the horizontal asymptote is at 0.5. So going upwards, going closer, 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 closer to 0.5. So I'm going to use 0.5 with parentheses. Then, since we're going to do another range, I'm going to use the symbol for and. Now let's take a look at the down and up arrows for the right graph. So we're going to start with the bottom half, which is the down arrow. So we can see it's going downward, closer, closer, closer to the horizontal asymptote. So closer, closer, closer to 0.5. So we're going to start with 0.5 again, comma, and then the up arrow, see, we can see that it's continuously going upward. So continuously means infinity. And again, both of these, parentheses. Because when it comes to asymptote, it's going closer, closer, closer to 0.5, but never crosses or touches, so that's why we don't use bracket. So our range is negative infinity to 0.5 and 0.5 to infinity. So here's our domain and range for our third example. Now for our last and fourth example, we have a graph of a piecewise function. So let's take a closer look. We have 3 graphs. So that means there's a possibility of 3 domains and 3 range. And then I noticed that there's circles at the ends on each graph. A closed circle and an open circle. So if we tie back to Algebra 2, when there's a closed circle, so it's in relation to inequalities. So we have a closed circle, that means it's included, so we're going to use the symbol for bracket. If it's an open circle, then we're going to use the parentheses. So again, closed circle, brackets, open circle, parentheses. So let's start with domain. So we're going to usually start with the left right here. And as I said before, there's a possibility of 3 domains, meaning that it could be 3, it could be 2, or maybe it could actually be 1. So let's see. I'm going to write the letter for domain. So starting with this one, and with respect to the x-axis, we can see that it starts at -4. And it's exactly at the intersection, so I'm going to write -4. Since it's at the exact intersection, I'm going to use bracket. And then comma. Then it goes towards the right and stops at -3. So if we look at this end right here, compared to the x-axis, it stops at -3. Funky negative. Okay, so -3. And since it's a closed circle, it's going to be a bracket. So now we're going to look at the second graph. So I'm going to use the symbol for and. So starting from the left of the graph, with respect to the x-axis, we can see that it starts at -3. So -3. With an open circle, so we're going to use parentheses, and then comma. Then going towards the right, with respect to the x-axis, it stops at 0, 0. So it's right on the mark of the intersection, so I'm going to use 0. That's where it stops with respect to the x-axis. But since it's right at the intersection, I'm going to use bracket. Alright, so let's take a closer look. Since those two functions that we discussed on domain, as you can see, it overlaps. And as you can see, there's a -3 on the left domain, and there's a -3 on the right domain. So, the difference between the last example was that even though there's two numbers being used the same, or I mean two numbers that are the same, both of them were parentheses, so they were split. Since we have two negatives, two -3s, one has parenthesis and one has bracket. Since this one has bracket, that means that -3 in the domain is included. So, in the event you have these two, and one of them is a bracket, again, if these two numbers are the same, and one is a bracket, you can actually combine these two domains into one. So, instead of this, I'm going to write the proper combined domain. So, we're going to start with the lowest value, which is -4, comma, and then the greatest, 0. Both brackets. Now the reason we could do that is all the numbers from -4 to 0 aligns with the graph, or part of the graph. So all the numbers from -4 to -3 are part of that graph, and numbers from -3 to 0 are part of that graph. So our domain for these two graphs is from -4 to 0. Again, we can do this when these two overlaps, when both of them has -3 and one of them has a bracket. So we can definitely combine these two domains as one. Now we need to do the domain for the right graph. So I'm going to use the symbol for and. Now, oh, that's a funky and. Right here, there's a space between this graph, the second one, and the third graph. So, since there's a space in between, that means that none of the values between 0 and 1 is going to be in a domain. So, we don't have to worry about combining as one domain. So, we're going to actually have a separate domain for this graph right here. So, starting from the left, we can see that with respect to the x-axis, it starts at 1. So I'm going to write 1 here, comma. Now since it's a closed circle, that doesn't mean I can use a bracket. And then going towards the right, again this graph is going diagonally, so it's going two directions, to the right and downward. But we're going to focus to the right for domain. So since it has an arrow continuously going to the right, so it's going towards positive infinity. Since it's going towards infinity, we have to use parentheses. So we're not going to use this domain since we combine these two as this. So this is the correct domain. So from -4 to 0 with brackets, and from 1 to infinity. So that's our domain. Now let's do our range. So we're going to start from bottom all the way to the top. That means we're going to start with the right graph here. Since that's the lowest, we're going to start at the bottom. So we have an arrow here, so continuously going downwards. So the lowest, if it's continuously going downward, it's going towards negative infinity. So we're going to start with negative infinity, comma, and then right here, with respect to the y-axis, going towards the top for range, we can see that it ends at -1. So with respect to the y-axis, it ends at -1. So I'm going to use -1. And it has a closed circle, so I'm going to use a bracket on that -1. But I'm using that parenthesis on the negative infinity. Alright, now let's take a look at those two graphs. So with respect to the y-axis, we can see that these two parts right here overlaps with this part right here. From 0 to 1 on the y-axis, from 0 to 1, these two graphs overlap each other. So it's pretty much the same as combining these two. So let's leave with this one for now, and let's talk about the range for those two graphs. So say I'm doing the range for the middle graph right here. So going from bottom to top, it's going to start at 0 on the y-axis. I'm going to write 0 here. And then it ends at 3 with respect to the y-axis with a open circle. So from 0 to 3, parenthesis on a 3 and bracket on a 0. Now bracket on a 0 because it's right at the intersection, parenthesis on a 3 because of the circle. Now let's take a look at the third graph. So say I'm doing multiple range, so I'm going to use the symbol for and. So if we look at respect to the y-axis, it starts at 0. So I'm comparing with the y-axis. Here's the y-axis, so it starts at 0. And it ends at 1. So, we're at 1. Since it's right at the intersection where y is 0, so I'm going to put bracket. And here, it ends at 1 with a closed circle, so also bracket. So our other range is from 0 to 1. Now, the reason I said that there's a possibility of combining these two ranges as one was because both of them have 0, and 1 is between from 0 to 3. So technically, I didn't have to write two ranges. I could write as one. So if you see two graphs that overlaps each other in terms of the y-axis, you can write these two ranges as one. So I'm going to write the symbol for and here, and then both of them starts at 0, so I'm going to write 0 and then comma, and I'm going to use 3 because this one extends longer. So from 0 to 3, bracket on the 0 and parenthesis on the 3. So I'm just going to erase this. We're not going to use this range anymore. So our range is from -infinity to -1 and from 0 to 3. Erase this. So let's review. Our domain for this piecewise function is from -4 to 0 and, what a funky and, 1 to positive infinity. And our range is from -infinity to -1 and 0 to 3. So that's the domain range for our fourth and last example.